Session in next 5 minutes. Kindly take your seats. I repeat, we are going to start with the next session in next 5 minutes. Please be seated. Hello, check. Okay, so let's take this meeting, these discussions to the next level. Okay, it's now time to start the next session, which is about integrating advanced technologies in mainstream agriculture. Agriculture in India is about economizing use of resources, improving production per unit of such resources, yet maximizing the gains to the farmers. This session will bring together experiences with similar technologies, the trends in adoption globally, and the scope of adoption in India. Now, for further proceedings, I would like to introduce you to Mr. Rotash Mal, the Chairman and Managing Director, EM3 Agri Services Private Limited, India. So, Mr. Rotash Mal was the CEO of Escorts Limited. Before that, he was CEO of Bharti Airtel and simultaneously the CEO of Bharti Del Monte Limited. Mr. Mal was the chief for sales marketing service for Maruti Suzuki Limited. He has over 36 years of corporate experience in a diverse range of industries, including chemicals, detergents, paper, retail, etc. He holds BTech from IIT Delhi and MBA from IIM Calcutta. I would now like to invite him to take over as session moderator.
Thank you for your kind introduction. A few opening remarks before we get going. The first one is that the word moderator needs to be removed from your sheets because I don't fancy myself as Arnab Goswami or in any case, he quit. But no, I don't think I'll need to moderate anything with my distinguished panel. Perhaps summarize, or perhaps at the early stages with a few thoughts, so to speak. We're going to be listening to four very distinguished people. And we have Dr. Iona from Greece, who's going to be talking to us about the Internet of Things and applications. Mr. Richard Klappholz from Israel, Rivulis Irrigation. Drip irrigation has been around for quite a while. We're going to hear about the next generation stuff. Dr. Yossi Shasham would be, I hope I got the pronunciation right, would be talking to us about sensors, nanosensors, and microelectronic applications in agriculture. And Mr. Samir Shah, who's the managing director of NCDEX, will speak to us about market access. I would request the panelists to talk a little more about themselves at the time. From my part, since I have removed moderator from my description, I'm going to talk about a few thoughts which concern me or impact me as somebody who is a customer of technology. And therefore, what is it about technology that... Look, I have this picture in my head about making a building, which is basically foundations, pillars, and beams, right? This thing only comes together if you have verticals of excellence, which are technologies individually. You have beams that actually tie these technologies, and the entire structure then what is a market model. And unless there is a benefit of delivering to the customer, in this case the farmer, via technology, a set of benefits, not features. Benefits which put more money into his wallet, which create more productivity for him. We're probably not doing justice to the entire problem. Somewhat like we have a lot of keys with us, but we don't know which locks to open. So to my mind, the bigger problem is defining problems far sharply, problems that have impact, before we start looking at technologies. And as technologies develop, making sure that application is equally in view. And those is what I call the beams to this structure. The second thing is this conference itself. We're talking about digital pathways to agriculture. So if this was a conference on manufacturing cars or manufacturing detergents, we wouldn't be talking about digital pathways. We're really not talking about something out of the box. We are saying that the same principles that run industry, and what is farming, what is agriculture, but a sigma of 100 million small factories which create value, right? Our business of engaging with farmers is a B2B operation. The farmer is a B, right? He runs a business. So how is it that we can add value to business? And if you look at the parallel of industry, what is it that you need? You need control of raw material, you need your factory to be in great condition, you need information, you need decision support systems, you need quality assurance, you need quality management, and finally, you have to turn your product and monetize it, right? Where market and market access comes in. So are we really talking about something dramatically different, or shall we have lessons from another world called industry and bring it right here into agriculture? And my own experience in agriculture is, out of my 40 years now since I came out of college, seems to suggest that there are many more lessons outside of agriculture than they are in agriculture. So to me, that's probably the other inspiration. Now, we're talking about data. When you're talking about IoT and so on, we're not talking devices. We're talking about that factory where you have an ERP. Now, obviously, in the traditional sense, ERP is not going to be operated on by the individual farmer. So models have to develop where ERPs are run for the farmer to his benefit. And how do we create those processes, those systems, and those connects to be able to run that factory, so to speak, to the benefit of the farmer? With those opening remarks, I now would like to invite Dr. Iona Rusaki to talk to us about the IoT of things in the agricultural system. Thank you.
Hello. Okay. Before the slides are up, I would first like to thank a lot about the invitation. I'm very happy to be here in Chandigarh and be talking about our research and the situation of smart agriculture in Europe in general. A bit about myself, my institute. I'm a professor at the National Technical University of Athens in Greece. This is one of the largest universities we have in the country and one of the most prestigious ones. I'm a professor in the School of Electrical and Computer Engineering, and I'm also affiliated with ICCS, Institute of Computer and Communication Systems. These two, NTUA and ICCS, have a very significant position in European research. Since the year 2000, we have been involved in about 1,000 EU-funded projects, and we have one budget of more than 300, 400 about millions of euros for our institutes. And in this respect, we have worked with several thousands of organizations, not only European organizations, but also outside Europe, and this includes not only universities and research institutes, but also large companies, SMEs, non-profit organizations, and so on. So my topic is mainly the Internet of Things. I'm not going to use buzzwords or technical talk to explain what this is about. In general, it refers to the case where objects, resources are able to get connected, and via this process of exchanging information, they become smart in a way. There have been a lot of research initiatives going on in IoT in Europe, but not, of course, not only in Europe, globally. There are several consultant companies that have made estimations on what the market will look like in a few years about IoT. For example, Cisco estimates that in a few years, by the year 2020, there will be about 50 billion of devices connected online, and this is the basis for IoT. This is our infrastructure. And the respective IoT market will worth in less than 10 years from now, up to 6 trillion of euros. And the estimates for Europe are more or less the same. The yearly growth rate is over 20%. So yes, the world is going towards IoT. There's a huge population of standardization organizations and alliances, ranging from business to consumer side up to business side, from low-level network connectivity up to services and applications. I'm not going to talk about them, just focus on a few. In Europe, we have the Alliance for the Internet of Things Innovation. AIoTI is doing a significant work in this area, as well as IRC, the European Research Cluster on the Internet of Things. On a national level, almost every EU country has their own initiative. In Greece, we have the Hellenic IoT Forum, a member of the steering board there. But this is a conference about agriculture, so yes, IoT is a unique tool to be used in agriculture. Based on a benchmarking study conducted last year by the European Commission, it's one of the most promising domains to adopt IoT, agriculture. There are various reasons for this, and the motivation behind adopting IoT lies within food security matters. We're expecting a population increase and increased food production requirements in the years to come. There are environmental pressures. The availability of resources is getting limited. Energy-wise, land-wise, water-wise, the climate is changing. We're losing biodiversity, so there are a lot of reasons we need to employ new technologies to promote agriculture. And of course, there's the financial aspect of the things that has to do with globalization and price variability. The market name for IoT being adopted in agriculture is precision agriculture, smart farming, or smart agriculture. These are the most popular names for IoT in agriculture. Basically, it's about applying the right treatment at the right place at the right time. This is a big issue in the farming industry, and to be able to deliver this, to support this, there is a wealth of technologies that need to be used, including satellite positioning, remote sensing, and of course, information engineering, AI, as was mentioned in the previous session. This picture, I like it a lot. It has been produced by Nesta, but I'm going to use it in this presentation. It gives an overview of how future farms will look like. Not huge ones, even small ones. So you see in this slide drones that are monitoring the field, and they're able to map the yield, to give details on soil based on image analytics. You see the agricultural robots that are involved in the process from planting the seeds until up to harvesting. You see smart tractors here. You see auto-guiding systems. You see the farmer being in front of a computer, checking out the status of his farm, checking out a lot of processed information that help him take decisions. Decision support systems or proactive automated actuation is also supported in this respect. And you see text and cows here. This has to do with precision livestock farming. These are monitored on an individual level. This is not the whole picture, but it's a significant part of it. I left out the satellite imaging part and smart irrigation that will be captured in the session as well. What are the benefits of adopting IoT in agriculture? First of all, it's financial. Motivation to adopt it, it's financial. The farmer will be able to reduce its cost without decreasing the production nor its quality. Preservation of resources as well. Improved operation and management on a farm level. Food security, as I mentioned before. Food safety and traceability. This stands from farm to fork. So from production throughout to the consumer. Another reason has to do with confronting and being compliant with environmental legislations that exist for the EU and will soon be valid across the globe. And of course, there are benefits from the social aspect and optimization of the working conditions of the labor workers and the farmer on the field. Some examples for applications and enablers, technology enablers that have to do with smart farming have already been discussed in the previous session, so I'm not going to go through this in detail. I'm just going to mention that up to now, based on studies that have been made in this area, the largest benefits of employing IoT in agriculture lay in the arable farming. Two of the most dominant applications that are being used in the market already is controlled traffic farming and auto-guiding machinery, where the soil combustion and erosion is being very limited, and also there's a huge saving of energy, as well as the variable rate application for all inputs that a farm may need. This last application is also used in horticulture and fruit and vegetable cultivation. Precision viticulture is one of the very successful examples we have in this area, precision irrigation as well. And I have already mentioned precision livestock farming, where animals are being tracked on an individual level with regards to their health, their status, emergencies, and so on. This diagram here indicates how the precision agricultural smart farming services have penetrated the market over time. You see that in about 15 years, your penetration has increased from 5 up to 15 times. Okay, technology is fine, we're convinced about the benefits, but there are definitely a lot of barriers in adopting this. From the sectors, the agri-food sector point of view, the main barrier a farmer has is the capital investment cost that is high. So maybe for a large farm owner or a large company that exploits land, it's within their continuous investment plan to uptake IoT. But for family farms, for small landowners, This is not the case. Furthermore, there's a huge heterogeneity in the sector. Not all solutions apply in everything, so we need to variate. There's a very different requirements for a vineyard in Greece or a paddy field in India. So we need to be very careful on what we apply and where. Business model-wise, new business models need to raise here. The existing ones don't work. There have been some experiments, some really successful experiments. For example, in Greece, we have one of a new business model. I will be talking about it if I have time. Technologically, there's still a lot of barriers, there's still a lot of things to solve. We do not have connectivity all over our farming lands. We lack data processing power. It's of no use if we have a decision support system that's able to apply in a few hours if we need to make a decision now. That's a huge number of standards that have arisen. This is a problem. This is not a solution. There's no overarching standard being able to bridge everything, so we still are not interoperable. We lack data governance mechanisms. We lack the necessary policies. There's a struggle between farmers and large companies over the data that are being collected in this system. And of course, as in most ICT systems, there are matters of data security and privacy that needs to be solved. On the farmer's view, more or less I have already covered. What I have not mentioned yet is that, unfortunately, there's still no detailed cost-benefit analysis assessment. So we cannot convince the farmer to adopt these technologies. And this has nothing to do with the installation cost that is high. There is no assessment of the environmental benefit yet. The perceived value that is for the actual farmer is questionable. It's not clear for them. Why should they invest money on buying IoT equipment? They're not convinced how their lives will be made easier or more profitable. It's a complex technology to employ, so people are not that much prepared to work with it, to adopt it, so they need to be properly trained. Compatibility that's linked to the interoperability that I aforementioned. And of course, unfortunately, there's limited access to independent advisory services. I don't know if this is the case in India, but in Europe, this is definitely the case. Going through the situation in India very briefly, I noticed a few similarities that there are with regards to Greece. The average farm size is very small, as in Greece, the smallest in Europe. You guys have a problem of resource availability, mainly with regards to water. Water scarcity is one of our main issues in Mediterranean countries as well. The reason I'm presenting here the Greek farmers' views on precision agriculture is the similarities that exist. Mainly my point here is that we need to train the farmers to be able to accept and adopt this new technology, raise awareness, and provide the necessary support. These are the similarities I talked about. Briefly going through one of our main initiatives here, there are a lot, but I think I already overdid it with time. We're part of a very big initiative, more than 100 stakeholders from industry as well as academia from 16 countries in the European Union. This aims to push for adoption of IoT technologies on a large-scale basis throughout the continent. And to do this, we do not only aim for technology advances and new business models, but we are also promoting the farmers' behavioral change and the user acceptance that I aforementioned. Finally, last slide, there are some opportunities for international cooperation between India and Europe. There are some H2020 topics, the big innovation and research program funded by the European Commission that Indian people, Indian companies are entitled to participate and get some funds from the Indian government. I selected only 4 topics, there are more than 20 that you guys, if interested, can target. Innovative agri-food chains, solutions for sustainable food packing, smart fisheries, there are a lot more, seafood, bees, plant health, and so on. So if you are interested in pursuing something like this, collaborating with European organizations, you can contact me. Some useful links, and that's all from me. Thank you very much for your attention.
Thank you, Dr. Sasaki. That was indeed eye-opening at a very high level, and I am sure when the time comes for Q&A at the end of the session, you should have a lot of questions coming at you. I now have the pleasure of inviting Mr. Richard Klappholz, CEO of Rivulus Irrigation in Israel, to talk to us about next-gen drip irrigation.
Hello, good afternoon. I'm very happy to be here today. One of the reasons is that I feel very rich today. I touched my wallet today. It is very thick, full of 100 rupee bills. Thank you very much for that. So my name is Richard, Rich, maybe not. My name is Richard Klappholz. I'm the CEO of Rivulus Irrigation. Rivulus is an Israeli drip irrigation company. I live in Israel, near Tel Aviv. I'm very happy to be here, as I said before. Some of you may know my company as with other names, Plastro in Israel, or John Deere Water as the John Deere unit. We became an independent company 2.5 years ago and renamed our company as Rivulus Irrigation. So we are a very traditional drip irrigation company. We are the 3rd largest worldwide drip irrigation company with 1,300 professionals worldwide, 11 factories, over 200 employees in India. I will talk today a lot about turning things into reality. We have already turned the Israeli-Indian cooperation into reality when the Firodia family of India made a very significant strategic investment in our company, and we are very happy to cooperate with them. I have Mr. Sudhir Mehta, who many of you know, on my board. I did not see him today, so I'm less under pressure for this presentation. So we have 1,500 dealers worldwide, so why the hell would a traditional drip irrigation company appear in this part of the session? What do we have to do with IoT, satellites, drone, and so on? We are fundamentally a plastic company, fundamentally a logistics and manufacturing company. What am I doing here today? Maybe, Mr. Mal, you have made a mistake to invite me. I don't know.
I am certain we haven't.
But, you know, one of the main challenges in drip irrigation is the adoption of drip irrigation. You know, drip irrigation companies talk a lot about higher yield, less water usage, better fertilizer usage. So why better quality of goods? You know, if you have ever seen a piece of corn coming out of a drip irrigated land, beautiful, strong, large, yellow corn as opposed to a non-irrigated land. So the quality is better, the yield is better, the savings are important. So why has adoption not been close to 100%? We talk about global adoption of less than 10%. It really bothers us. If we could move the adoption rate from 10 to 20%, we would be billionaires And who does not want to be a billionaire? I want to become a billionaire. So, there are few constraints. One of the constraints that there are many constraints.